Hey, there's one thing that you're going to need to know for the homework that we didn't cover yet in the hybrid homework, going through it in class, which is the correlation function. We're going to talk a lot more about this on next Friday, the coming Friday, but you might need it for doing the homework that's due on Sunday. So all you're going to do is, there's a question that says, here's some numbers, what's the correlation between the numbers? So you'll have something like 78, 74, 36, and 95. And then you're going to have a second group of data that says, 65, 70, 27, and 81, right? Okay. The data that you're actually going to have that comes from your homework is going to look more like this. So you're going to have something like that, where you have the student over here, and there's numbers for which student. You've got exam 1, you've got scores coming down, you've got exam 2, and you've got scores coming down, and you've got averages. So this question is designed in a way, I don't want to say to trick you. It's not really to trick you. It's to help you practice knowing what data here is actually the important data that you need to get. Okay, so the student number that has been assigned to these people, it doesn't mean anything. It's just like, here's a number, right? 1, 2, 3, 4. It's in place of a name. So it's a nominal variable. It doesn't actually tell us anything about what skills they have, how they've done, performance, anything like that. It's just a name. So we don't need that at all. And then the average, so what we want is exam scores, and these are good. What we don't really need is the average, because the average is averaging all these students together. That doesn't tell us if there's a correlation between exam 1 and exam 2. We want to see how this person, student 1, does on exam 1 and exam 2. Is there a relationship between those exams? Averaging everybody together isn't really going to tell us if there's a correlation between the two exams. For example, if we did something like, what do we want? 7 and 3 and 3 and 7. Like, say they're rating different foods. Chocolate and broccoli. These are two different people. One person rates, there we go. So one person rates chocolate a 7, and they rate broccoli a 3. The other person rates chocolate a 3 and broccoli a 7. The average for both of these is 5. If you're only looking at the average, you'd say, dang, this is like a correlation of 1, because the score that chocolate gets is the same as broccoli gets. But actually, if you look at the data, that's not what's going on. It's like, in this group of people, they either like chocolate or they liked broccoli, not both. And so there's not a correlation between these numbers. So you don't want the average. That's not a helpful piece of data when you're trying to compute a correlation. The average is something you want to leave off. So we're going to get rid of that. And you're left with these 8 numbers here, which are the same numbers that I have here. So if you want to figure out the correlation between the two, you're going to put a formula into Excel. And since it's a formula, you're going to start it with equal sign. The command for a correlation is just CORREL, and then open parenthesis. Now we've got an array that we have to put in. This is going to be a little different than what we've done so far, because up until now we've just been going like A2 through A501 and done. But we actually need two arrays here. So we're going to do A1 through A4, and see, that just gives us the first set of data. And then you're going to put in a comma. Next, you want to do B1 through B4. So essentially what this is doing is it's saying, give me the correlation between exam 1, and we have to give it the range for exam 1 and the correlation for exam 2. Here's the range for exam 2, and then hit enter, and it's going to do it. Excel knows that this score and this score go together. This one and this one go together. This one and this one go together. Like, it just knows that. If you jumbled them up, you would get a different correlation because it's going to pair them together across in rows. Okay, so hit enter, and we get a correlation of 0.98. This is a super high correlation. Remember, correlations range from correlations range from -1 to 1. And the strength of the correlation is the distance from 0. So you can think about it like east to west directions. You know what? We all live in Phoenix. We can talk about this like this. And in Phoenix, you've got avenues to the west, streets to the east, and central is the 0. So you could think about, like, the negative or positive on here is just street or avenue, and the number, like 16th Street is the same distance from 0 as 16th Avenue. Like, that's what the positives and negatives are for correlation. It's just direction. It doesn't mean how far it is or how big it is, the magnitude of the correlation. For magnitude of correlation, it's just the distance from 0 to 1. Absolute value of the distance. So this correlation here, 0.98, it's really big. That's a strong correlation because it's huge. If it was -0.98, it would be just as strong, just in a different direction. So that's going to help you do that homework. There's a question or two like this. Don't be afraid to use Excel to help you do the homework, because it's the program we're using. So, and it's really good at this kind of stuff. All right. I'll see you on Friday.